Good afternoon, and welcome back to the Nutrient Management Seminar Series for February 22nd. Today, I have the pleasure of welcoming Dr. Frank Larney, who will be presenting on Feedlot Manure Composting, Where Are We At? Dr. Frank Larney is a research scientist in soil conservation with Agriculture and Agri-Food Canada in Lethbridge, Alberta. He grew up on a mixed farm in Ireland and holds a Bachelor of Science in Agriculture and a Master's and a PhD in Soil Science from the University College Dublin. His research expertise includes soil health, soil erosion, soil reclamation, beef feedlot manure management, organic amendments, and dryland and irrigated cropping systems. His publication record extends to 180 peer-reviewed journal papers and 16 book chapters. Frank has served as president of the Canadian Society of Soil Science and editor of the Canadian Journal of Soil Science, and is a former adjunct professor of the University of Lethbridge, the University of Alberta, and the University of Manitoba. He was honored with fellow awards from the Canadian Society of Soil Science and the Soil Science Society of America for research accomplishments in soil science. Frank, thank you very much for presenting today. Really looking forward to your presentation.
Okay, I'm going to start my presentation, Feedlot Manure Composting. Where are we at? And thanks to Brad Calder for inviting me to make this presentation to you today. I'm Frank Larney with Ag Canada here in Lethbridge, and I'm going to talk to you about feedlot manure composting. Where are we at? So just sort of a general slide here first about organic amendments, and you may see them referred to as byproducts, wastes. I generally don't like the term waste, but unfortunately that's what we've come to call these organic amendments. I think organic amendments is a much more positive connotation. So they include manure, compost, and that can be agricultural compost, urban compost, municipal solid waste, for example. Biochar, we hear a lot about recently. Biosolids or sewage sludge is another organic amendment. Depending where you are in Canada, there's options for pulp and paper byproducts, which can also be land applied, contain organic matter. If you're doing anaerobic digestion, some of the solid materials that are left over at the end of that process to digestate, also an organic amendment. And then there's lots of byproducts from food processing, for example, sugar beet, potato processing wastes. So a lot of that can be land applied as well. So I guess it's much broader than manure or compost is what the point is here. And when we talk about fertilizer, we've got our nitrogen, phosphorus, and potassium, and other micronutrients in fertilizer. But when we talk about organic amendments, essentially we have those NPK, etc. But the main is that we have carbon actually. So it's a means of putting carbon back onto our land and replenishing soil carbon levels. So when we apply organic amendments to the soil, there's effects on soil properties. So what are some of these effects? Soil organic matter and biological environment. So with that carbon is the main component of organic matter, we can increase soil organic matter content, which is always a good thing for our soils. And that can affect soil biota or soil microorganisms, bacteria, fungi, and we can also get what we call aggregation, or sort of a meshing of aggregates together to give that soil a good structure. And you've heard that term soil tilth. It's sort of an old term that we used to hear a lot about, but that really just sort of describes how well aggregated a soil is. And that process of aggregation can kickstart soil restoration. For example, if we've got a degraded soil, we apply manure to it, the early stages of that involve aggregation in terms of getting a soil restored or rehabilitated. In the organic amendments, there's also nutrients, like we mentioned, nitrogen and phosphorus, nitrogen mineralization, manure, and compost more so as the ultimate slow release nitrogen. Phosphorus in organic amendments, and sometimes fertilizer phosphorus can be immobilized by calcareous soils, which we have here in southern Alberta. But the phosphorus in manure can actually be more readily available for uptake on these calcareous soils. And on acid soils, manure actually has a liming effect, so it can increase the pH for some of these acid soils, especially in the grey wooded area. Soil structure, so these are properties like soil porosity, the aeration, the pore space, and sort of aeration of the soil. And the flip side of that is bulk density or soil compaction. So generally, organic amendments can improve porosity and aeration and decrease soil bulk density and decrease compaction. And that in turn has effects on soil water. Generally, organic amendments can improve the water holding capacity and make the soil have more plant available water. And it also helps the movement of water within the soil profile. It can increase infiltration and hydraulic conductivity, which is basically water flow within the soil. So this diagram here basically shows how all these soil properties, the physical, the chemical, and the biological, come together. And in the middle there you have soil health. And we hear a lot about soil health these days. We used to call it soil quality, but I think a lot of people became much more interested in it when we call it soil health. So you'll hear a lot about that. So organic amendments fit into the whole soil health scenario, and that list there on the left shows that they affect physical, chemical, and biological properties. So they really fit into that diagram there. There's a Soil Health Institute in the United States right now, and we've actually been doing some work with them. We've let them sample some of our long-term plots here at the Ag Canada Research Centre in Lethbridge, and they've got some really good results for us in terms of soil health parameters. So let's move on to manure, and first we look at traditional manure handling. Focus here largely on the feedlot industry. That's the area I've worked in most over the years. So, this term was coined many years ago, the bullseye effect with manure application from, say, a feedlot. So basically, the fresh manure is hauled very short distances from feedlot pen to field. So most of that manure actually ends up on land that's close to the feedlot source. So that land can generally, sometimes receive too much manure. And when we have over application of manure, we run into issues with soil, water, and air quality. And then the flip side is that land distant from feedlots can be nutrient deficient. So the question then is, can composting help? Change how far we can actually transport the manure nutrients from the feedlot source. So I generated this data here. It's a map of southern Alberta, and it's actually quite difficult to get information, get statistics on manure and how much manure is actually turned into compost. And Stats Canada, the 5-year, every 5 years you do the Census of Agriculture. But unfortunately, the consistency of the questions that are asked hasn't been great. So sometimes, certain questions are asked about manure, and then the next time they're not, or the question is different. So it's quite difficult to actually get some good stats. But what I've done here is actually looked at the number of farms producing or using manure and then express that as a percent of the total number of farms. So you can see there Lethbridge County is the highest at 37%. So 37% of farms, of all farms in the county, actually are producing or using manure. So there's a difference. You may be producing it and using it on the same farm, or you could be producing it and then sending it to your neighbor to use on their farm. So this is not actually the land area, it's just simply the number of farms. So, and a farm is defined as anything from 4 hectares of land up to 1,425 hectares. So quite a big variation there. It would be nice if we a basis, like the number of acres or hectares that actually got manure, but we don't. But what I wanted to show is actually where, you know, Lethbridge is the highest at 37%, which makes sense because we have the highest livestock numbers. And then you go to the county of 40 Mile, for example, it's down to only 16% of farms actually in that county are producing or using manure, you know, compared to the total number of farms. So this is another map here of Canada this time, and it's sort of urging us to spread it around in terms of manure. So it's a percent cropland area receiving manure, and this is in 2015, so the year before the 2016 Census of Agriculture. And you can see here that the numbers are extremely low for the prairie provinces. So basically 5% of the cropland in Alberta received manure in 2015. So it's very low. Saskatchewan only 2%. So there's a lot of land area. You know, basically 95% of the cropland in 2015 in Alberta did not receive manure. And then, you know, you compared that with, you know, further east, 20% in Ontario, so a lot higher. Quebec is 46%. You know, and they don't, this is mainly, I think, due to the smaller farm size in the east, and also that they've got more dairy operations, hog operations, maybe poultry operations that we have here on the prairies. So it's surprisingly low actually on the prairies how much cropland receives manure on an annual basis. So we need to spread it around more. So, you know, lots of times when people ask me, look, what I work on, and if I say manure, they sort of look at me like, wow, you know, that's, that they kind of look at me like that, kind of sorry for me. But when I say I work on compost, then, you know, their eyes light up and we can have a really good conversation. So I think it's just sort of the wording of manure and compost. And to me, they're sort of, you know, they both contain nutrients. They're both really good soil amendments. But composting has sort of got a much more positive connotation. And I know for anyone living in an urban setting, you know, backyard composting has become very commonplace. I think the awareness is much higher now than it used to be. A lot of people have backyard compost operations, composting their kitchen waste and their leaf and yard waste that they can collect. So this is really taken off actually in urban areas. And then the other end of the spectrum is in agriculture and as a means of handling our manure. This is an example of a windrow turner, a self-propelled unit turning compost at a livestock farm. So in terms of just some of the basics of composting, composting 101 we call it. So, you know, what is it exactly? Well, firstly, it's a natural process whereby organic matter is turned into stable humus-like material under managed conditions. So I think, you know, the managed conditions is where the composting part of it comes. Like it is a form of manure management. We're not just letting the manure sit there. That's more like stockpiling, you know, where we clean out pens, stockpile the manure and let it sit there till it's ready for land application. That, you know, that's the stockpiling option. But the composting is where we actually go in and form it into long, narrow windrows and then incorporate air into those windrows by turning the manure roughly 6 to 8 times over a 3-month period. And then you let it sit for a further 3 months in what we call the curing phase. So we've been doing composting research at the Research Centre in Lethbridge since the mid-90s, and that's our tractor pull windrow turner there on the top right, and that's our composting site there at the bottom. So basically it's not just the manure that we compost, a lot of organic material, stuff that comes out of our greenhouses, potting mix waste. There's a lot of straw or stuff that we don't use on site. That's anything organic can go into those windrows and get turned into compost. So in terms of the science behind composting, so this is our compost windrow. So the manure is put into a windrow, so the raw manure going in. It's got organic matter, carbon and nitrogen, minerals, water, microbes. We turn it and incorporate oxygen. Water is released during that process, so a lot of the weight of raw manure is actually water, so we can lose a lot of water during composting, which is good from a transportation point of view. It also gives off heat, and that's a good sign. It means that the microbes are doing their work and turning that manure into compost. And then we get some gas emissions. So we get carbon released as carbon dioxide and methane, and then nitrogen as ammonia and nitrous oxide. So 3 of these 4 actually are what we call greenhouse gases released. And then at the other end, you end up with finished compost, and you'll see there that it's exactly the same in terms of organic matter, minerals, water, microbes. I mean, the same components, but just the actual amounts are different, and the stability is different in compost compared to raw manure. So moisture is one of the main parameters that we look at. It's very important if we want composting to be successful. And a major drawback of summer composting is loss of water on turning. So sometimes spring, our moisture content at pen cleaning can be fairly optimal. But then once we get into, May, June, July, we can get a lot of evaporation, warm temperatures and a bit of wind, and that water loss can be too high. So if the compost windrows get too dry, say they drop below 40%, the microbes just shut down, and you end up with dry manure, basically, rather than compost. At the other end, if it's too wet, you get a lot of that pore space filled with water, so greater than 70% water content. There's not enough oxygen then, and things shut down as well due to lack of oxygen. So that just right sweet spot, the moisture content, about 50 to 60% is what we're looking for by weight. So sometimes actually winter composting can work quite well. We get better water retention because evaporation is pretty much non-existent in the wintertime. And then temperatures can be maintained in cold weather if the windrow dimensions are large enough. So basically, if the windrows are wide enough and tall enough, and there's enough bulk material there, and we get our temperatures up before it turns really cold, it can be sort of self-propagating in terms of keeping that composting process going. So I've seen, even when we get down to minus 40 in our winters here, you can have temperatures of plus 60 internally in a compost windrow if things are going okay. So the other successful parameter we look for is windrow temperature. And this graph here shows the days of composting on the x-axis and our temperature on the y-axis. So we've got 3 locations in the windrow: the bottom, the middle, and the top. And then we've got that straight line there at 55 degrees C, which is our thermal kill limit. So that's the threshold temperature that you want to get above in order to get a good kill of pathogens and weed seeds during composting. And you can see here, this example, we've got a substantial amount of time where our windrow temperatures especially at that bottom and middle locations, are above 55 degrees C. Our top location, that downward arrow there, you can see is a lot cooler, but each time the compost is turned, that cooler outside material is actually turned into the center of the windrow, into the middle location. So that mixing actually makes sure that all of the compost matrix is actually subjected to higher temperatures. So what are some of the benefits of compost versus raw manure? The main one is the reduced volume, and in turn the reduced transport requirements. So there's quite a bit of shrinkage during the composting process, and that's, I think, the biggest benefit, in that there's less material to move around in terms of finished compost versus raw manure. People will actually give you money for compost, so it's a saleable product. Whereas with raw manure, lots of times you're essentially giving it away. Improved handling, it's more uniform, more homogeneous than raw manure, because it's been processed and turned and mixed, and it handles easier. It's not as lumpy or clumpy as raw manure is, and that in turn leads to more uniform land application. There's less variable nutrient content. It tends to be, like I say, more homogeneous. So from batch to batch, you would expect to have less variation in the nutrient concentrations once you process raw manure into compost. It's generally applied at much lower application rates than raw manure, so therefore the pollution potential is a lot lower. If composting is done properly, the finished compost product should be essentially odorless. So compared to applying raw manure, you're way less likely to get odor complaints from compost application. You get the benefits of pathogen and weed seed elimination. If you get those temperatures up below 55 or above 55 degrees C, you can essentially get rid of those undesirables, let's say, in manure, like pathogens and weed seeds. And there is some information actually from the literature to say that compost application can actually suppress diseases in some plants. So that's another benefit. In terms of weed seed viability, this slide here shows percent viable seeds versus days of composting. This is a project we did back in the early 2000s at Lethbridge. So we've red root pigweed there, and we've got control and composted. So this is where we buried weed seeds in mesh bags in compost windrows, and then we pull the mesh bags out on various days of composting, so 14, 21, up to 70 days. So you can see there, and then we try to grow out the seeds and see if they would germinate. So you can see there in the control, over 70% of the red root pigweed seeds were still viable, whereas in the compost, 5% were viable on day 14, but once we got to day 50, 0% were viable. Wild buckwheat, overall the numbers were lower in the control, but you can see here in the compost, it actually, they were less likely to get killed off. So 1% were still viable after 70 days for wild buckwheat. So in terms of nutrient dynamics during composting, nitrogen concentration decreases. However, the nitrogen remaining is in a more stable form than in raw manure. Also, our carbon concentration decreases, but again, the carbon remaining is more stable than raw manure. And then phosphorus is actually the opposite of nitrogen and carbon. The concentration of phosphorus actually increases because phosphorus is generally much less mobile than the other two. So essentially what you have is the same mass of phosphorus, and you lose some dry matter during composting. So it's the same mass of phosphorus and less dry matter, which means the concentration actually increases during the composting process. So like I mentioned earlier, moisture content important, and this is just a a graph to give you an idea of what sort of moisture levels can be like during the composting process. So starting out at 70% and then getting down closer to 30%. 180 days, that's basically 6 months. So that's at the end of the curing phase. So much less water in the material in finished compost. Volume loss I mentioned earlier, or shrinkage. So again, the initial volume, at the end of the composting process, 65% of initial volume. So there's a lot of shrinkage of the material, which again is important for transport. Bulk density. So this is basically the weight in a given volume. So it's increasing during the composting process. So you can, if you've got a truck, so many yards volume, cubic meters volume, you can actually put more weight into that truck in compost compared to raw manure. So this haulage scenario with feedlot manure. So this is as is on an equivalent wet weight basis. So if we've got fresh manure, 650 kilos per ton is water, 350 dry matter, 5.6 nitrogen, 1.6 phosphorus. If we take that same ton of fresh manure and turn it into compost, we actually flip around the water dry matter ratio. So we've got 360 kilos, 36% of the weight is actually water, 640 is dry matter, and we've got 9 kilos of nitrogen and 3.3 of phosphorus. So for nitrogen, we've actually, it's got 60% higher nitrogen on an as is wet weight basis, and 106% higher for phosphorus. So in terms of transportation then, we're actually able to haul more NMP in that compost on an as-is basis. So it's more economical to haul NMP as compost instead of manure. So we've got a source here, and we haul it 1K. Those soils, like I said earlier, are pretty much likely to have enough soil nitrogen and phosphorus already. So we go 30K out to soils that have low soil NMP, and as compost we can haul that a lot further. I think my truck has disappeared off that slide there. But anyway, I just wanted to show you the distance that we can haul. So, we've talked about benefits of composting. There are some drawbacks as well. You do need land to set up a compost pad or a site, so you can set up your windrows. There are odor issues with composting, especially early on in the process. If it's not managed properly, you can have issues related to odor. Weather has a huge effect. If it's hot and dry, like I mentioned, moisture loss. Too cold, you get freezing of windrows. Heavy rainfall can generate runoff, and if the pad gets saturated, you can't have access with your windrow turner. And we found, unfortunately, that in our Chinook winds here in Lethbridge, finished compost can actually blow quite badly, and the windrows can actually lose a lot of material that just moves in the wind. So that's not good. You need to do some marketing and finding buyers and managing inventory and quality control. It's a slower nutrient release, compost, compared to raw manure. So in terms of when to introduce it into the crop cycle, carbon and nitrogen losses, greenhouse gas emissions, and I put asterisks beside those because they happen for all types of manure handling, not just composting. So, cross-sector benefits. For the livestock sector, composting is a means of moving nutrients further afield. So getting nutrients from high loading to low loading land, which is a good thing. The crop sector, it can enhance soil quality and soil health. The oil and gas sector, it's a really good soil amendment. Compost is for well site pipeline reclamation, and we've done some work in this area as well in the past. There's still some compost knowledge gaps, we'll call them. Soil health, microbial activity. I think there's still some questions to be answered there. Nutrient release characteristics in terms of when to apply compost at what entry point, say in a rotation, fall application, spring application, and then its behavior in cropping systems, like how it fits in. Like I mentioned earlier, plant disease suppression, imported versus indigenous organic matter in soil reclamation, not just in soil reclamation, but soil management in general. So essentially, when you apply compost, that's considered like imported organic matter. Indigenous organic matter is where you actually would grow it in situ. So, for example, a cover crop or a green manure crop that's grown on the land and then worked in. How is that different from compost, which is actually imported into the system? And my guess is that the plants probably don't really care in the long run. Economics, we could also always fine tune the economics of composting. And statistics, like I mentioned earlier, it's hard to get good numbers in terms of the adoption of compost in the feedlot industry over time. So I pulled up this. This is another graph I have here, or another map, I should say. So it's based on the 2011 Census of Agriculture. So it's the year before that, 2010 growing season. So basically the question was asked, do you use other manure? And what they meant by other manure in the question was composted, processed, dried, or stored. So that was, I guess, anything that's different from fresh manure or raw manure. And then, so I've taken that, the number of farms using other manure, and expressed as a percent of the number of farms producing or using manure. So that's all types of manure. So you can see here actually that, and this is 2010, that 21% of Alberta farms who were producing or using manure were using what they called other manure. So that was some kind of processing, but they lumped composting in with, I guess, whatever other types of processing you would do. So 21%, which I thought was pretty good, in terms of, but they didn't ask that question actually in 2016, that same question. So there's no way of knowing how that changed in the 5-year period there. Now, just looking down east again, Quebec is only 5%, and again, that's because of the mix of livestock species, and they tend to have more liquid manure down there in Quebec, and that's more difficult to turn into compost than solid manure that we have here in Alberta. And just to reiterate that this is not percent cropland area. It's the number of farms using other manure, which includes composted manure, over the number of farms producing or using manure. So it's not an area in terms of hectares. So I mentioned, the solid liquid manure split on manured land. This is from the 2016 Census of Agriculture. So basically in Alberta, 80% of the manure is solid going on to manured land, and 20% is liquid. And the same in Saskatchewan. It changes in Manitoba, so less solid, 55%, 45% liquid. Mostly due, I think, to the number of hog operations in Manitoba, so more liquid. Ontario is 60-40, and then Quebec is only 40% solid and 60% liquid. And then the Maritimes, the numbers are quite small down there. So, but again, so I think 80% solid manure in Alberta means that the options for composting are higher than, say, in Quebec, where 60% is liquid. And with liquid operations, generally they have to separate that liquid from solid components before they can even think about starting to compost. So there's an extra step in there. So I guess what I'm saying is in Alberta, because we're dealing with a lot of solid manure, going the composting route is probably less difficult than it would be where there's a lot more liquid manures in the mix. So I'll just finish with this nice piece of art here from the 1800s, Jean-Francois Millet. So to show that, applying manure, it's an age-old, I guess, technique in managing our soils. But in recent times, unfortunately, it's sort of gotten a bad rap. And, maybe composting is sort of a bright star on the horizon in terms of manure management. But like I say, it's nice to get some better stats and see how things are changing in the manure management area. So with that, I'd like to thank you for your attention today, and I'll be happy to answer any questions. Thank you very much.